and it's taking too long for me to download them. So there's a little section here on hair. What I would expect you to know in general from the 2 or 3 slides that you have on hair, which I can't seem to get in a timely fashion. You should know that the hair shaft is generally exterior to the surface of the skin. The bulb and the root extend all the way down into the dermis in most cases. The dermis has to, the bulb and root have to be in the dermis. Typically, the root of the hair, the bulbar root of the hair shaft, overlies, it lies just on top, one of those dermal papillae. So in that dermal papillae are going to be blood vessels that allow the hair to grow. So the shaft is exterior. The bulb or the root are going to be within the dermis. The shaft itself will typically have a medullary region, which is the interior. Well, you should have the illustration, right?
Well, I was just thinking about the fingerprints.
Oh, I'm sorry. Thank you. I'm sorry. I was so upset by not having the slides. Did anybody come up with a solution? Obviously, the answer is the fingerprints are there for forensic identification, right? What are the fingerprints for? All right, so Bob says gripping better, very plausible. That has been tested over the years. And what has been found, what most of the studies have found, is that it does help a very, very little bit if whatever you're picking up is smooth and wet. And then, if you're eating fish a lot, maybe. But otherwise, it doesn't seem to confer much advantage. There must be at least a dozen different theories about it. It's kind of like why we have body hair. Does anybody figure out why do we have body hair? That's another story. Let's read about fingerprints first. Any other ideas?
Increased sensation.
So how so?
More surface area.
Okay. But why would they have that specific confirmation at that interval? I think you're on the right track there. At least that's the predominant theory. Anybody know what a washboard is?
Yeah.
All right. So if you ever watch the bluegrass band, they always have somebody blowing on a jug, and then there's somebody playing the washboard, and you'll notice that as they change the rate at which they put the hard object against the ridges of the washboard, that changes the rhythm. Clack, 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 clack. Can you think of any application of that analogy to the fingerprints? If you are, let's say your eyes are closed, you're waking up in the morning, or for whatever reason, you want to understand the texture of the edge of your computer. They're getting really sharp now. I almost hurt myself. But what is more meaningful to you? Those just putting your finger on it or running your finger across the edge? Why would you do that? Yeah, I think so. The usual explanation is that what you're doing when you're rubbing that sharp surface or that textured surface is that you are generating little vibrations that are picked up by Pacinian corpuscles and free nerve endings and so on. And then your brain has the ability to make some sense out of it. So whether accurate or not, that's the prevailing theory. And the next time maybe somebody can tell me about why we have hair. Tell me about the waiting ape hypothesis, so on. In any case, I don't seem to have the slide. That was the point that I was making here with respect to the hair. I don't suddenly show up. Oh, goodness. I don't know what's happening. All right, so this makes no sense whatsoever. But in any case, I was talking about the shaft and the bulb. I just brought up the slide and it wasn't there. So there's the shaft is exterior, the bulb is interior in the dermis. Oftentimes, as we've indicated, the hair similar into the epidermis and dermis will be associated with the rector pili muscle. The rector pili muscle is smooth muscle innervated by the autonomic nervous system. You've heard reference to the hair stands up on the back of my neck or arm or whatever generally implies some type of autonomic excitation. Then we've seen that there are sebaceous glands associated with the hair shaft. Also, there can be hydrosis glands, sweat glands associated with the hair shaft. We talked about the distinction there. Apiquate, for example, apiquate glands. So we've indicated the hair shaft normally consists of a medullary region, usually a cortex. Medulla is always anterior to the cortex. And then there's this cuticle, and this is what you normally see in the micrographs. It looks so neat. That varies from individual to individual. You can see the little the electron micrographic representation up there on the right of the medulla and cortex. What isn't so clear in this illustration is that typically there is a region of melanocytes down here, boundary of melanocytes, and they not only are important for this area down here called the matrix, the matrix up there, the matrix, but this is where the hair acquires its coloration from those melanosomes we talked about before. Depending upon where the hair is in the body, here we're talking about scalp hair. The hair has a more or less predetermined interval of growth, at which point, when that interval is passed, in the case of scalp hair, usually 2 to 6 years, that's called the anagen stage, the hair will stop growing. Growth will be arrested, usually called the catagen stage. And at that point, as you can certainly witness by my example, hair falls out. And if, depending upon, again, your age and a variety of other circumstances, another hair will grow in its place. So typically you have this sequence of phases, anagen, catagen, telogen, and then return to anagen, depending upon, again, the age, the endocrine factors. What tends to happen in males with DHT receptors is that this process generally isn't repeated. Generally only occurs in youth of the high concentration of DHT receptors. How long is the longest hair you've ever observed? How long can human hair grow?
5 feet.
Have you ever seen, can it grow the length of the body, for example?
Yes.
You've seen? It's not supposed to. Generally, I guess unless we have a distribution here, I've never seen that. I guess the longest I've seen was a community college teacher in Arkansas, and it was about to her knees. But at that point, it's supposed to drop out. That's on the tail end of the distribution. So I wonder if these people have little artificial, what are they called, extensions? I don't know more about it. It's something I have an active interest in, so let me know how I can get hair going down to the floor. So you can see the hair shafts erupting through the epidermis here. All again, this is all cornified tissue typically surrounding it, so those are just husks, and that's why it has the disheveled appearance that it does. Here's the cuticle out here, the electron microscopic representation. Here's a split end. I'd like to have a split end. That would be an indication of hair being present. And of course, some good buddies over here. Aren't these beautiful creatures? Head louse. You've probably heard of genetic hypertrichosis. This is a genetic condition. There's no essential pathology here. These children seem to be very happy. It is more common in certain families, often in the South Asia. This is my current plan. I don't know if any of you else of you are using this, but I ordered several of these. Just don't say anything when they arrive if you don't know. So I told you about those. Another manifestation of that keratin would be the nail. I think the only points that we should stress in here, just be familiar with the general anatomy of the area around the nail. The plate, this would be the plate here. The plate rests upon the bed. You can see the nail bed there. The lineal, referring to its shape, moon-like, is back here, and is actually just an increase in the thickness of this region. You look at your nail anterior, actually that's not the proper term, and opposition, it would be distal. To the lunar, it looks a little pink, and once again, that's largely because of the proximity of the integumentary capillaries. And back here, because this, you can't see it here, but because this bed is thicker, you don't see the capillaries as much. We've talked about the matrix with reference to a hair shaft. The matrix for the nail is also back here where it originates. If you've ever lost a nail, you know that it tends to regrow over time from the proximal region there. And then the hyponychium, sometimes you'll hear it pronounced hyponychium, but I think hyponychium is preferred, is just this region that would be of importance to you because this is a region that is often injured, often prone to infection and mechanical disruption. The cuticle that you see here in the eponychium was just basically folds of skin. There's nothing magical or special about that. It's just basically folds of the outer skin overlying a portion of the perimeter of the nail. Does this inspire you the same way that the hair to the floor inspires me? She has fingernails 19 feet 9 inches long. I wonder how she sleeps at night without killing herself. Or somebody else, for that matter. All of you use soap and detergent and shampoo on a regular basis. Remember the brown fat revolution? Well, there's another revolution out there that basically argues that those things are actually destructive and inimical to your health. And there are a number of individuals who have, not only are they not using soap products to cleanse the skin, they are using products to increase the number of bacteria on the skin. So I'm not sure that would work out in a classroom situation in case, but in any case, there have been several reports. I think 60 Minutes had a program on this. I know PBS had a program on this movement. We talked a little bit about the organization of and the shape of glands in the skin. Now, remember these are all exocrine glands. They're releasing their product onto the surface of the skin. There are a variety in terms of their function. There are sebaceous glands that release oil to act to keep the exterior skin flexible and prevent it from breaking due to desiccation. There are sweat glands, also called sudoriferous glands. If you are hypersudoriferous, what does that mean? Yeah, you sweat too much, and we'll talk about what might be done for hypersudoriferous individuals, how we might treat them a little later. And we talked about the American and African. Bob was asking about this. I think the problem I have with this distinction is that this is more of an anatomical distinction now than a distinction with reference to the mode of secretion. What has been found is that apocrine glands are also primarily merocrine in their mode of secretion. So now we generally refer to apocrine glands as those in the axillary and urogenital regions, predominantly. We've already talked about the shape of glands, the tubular, simple, compound, and so on, so review that terminology if you need to. Previously, we discussed the ability of the skin to protect against UV radiation. We indicated that the melanin is important in that regard. This is a little bit dated. I think it's largely accurate, but I need to update this a little bit. If you look at the figure over here, what you'll note is we have a representation of the skin there, and then we have these long bars here that refer to the wavelength of light. And so generally visible light is what, 400 to 700 nanometers. And so the UV, it's not well indicated here, but the UV is going to be to the left of that for the most part. Now what do you notice? What pattern do you notice with respect to visible light and UV and its ability to penetrate the skin? Anybody see a pattern? For example, can visible light penetrate the skin? Yes, very easily. But visible light, because of its long wavelength, and there's a table here ripped off from the Wikipedia that shows you the relationship between wavelength and energy. Remember in your basic physics and chemistry, you learned that there's an inverse relationship between the two. So light at visible wavelengths, very long wavelengths, can penetrate very deeply into the skin, but it's not damaging because the energy associated with those wavelengths is so minor. So what is the trade-off here? As you move toward the UV, and you move in this direction, the energy increases, but what decreases? Yeah, the ability of those wavelengths to penetrate the skin. So that's, I think, the main point that I want you to see. As we move out toward from UVA to UVC, UVC is potentially much more damaging, but because it does not penetrate the skin as much, really, I think that the general counsel now is you should be concerned about all of these. If you were to talk to a dermatologist, I think they would argue that there's risk associated with all types of UV radiation. But certainly as we get into the B range, that is both very damaging and has the ability to penetrate to some extent into the skin. And there are a number of consequences of the UV radiation, photoaging, photooxidation, that it is potentially oncogenic. By that we mean that the UV radiation can cause breakage in the DNA, disrupt the regulatory processes of the cell, and perhaps cause that cell to go out of control with respect to its ability to replicate. Again, sunburn, skin cancer, accelerated aging, generation of free radicals, mutagenic activity, eye damage. All of these are potential consequences of overexposure to the sun. Of course, nowadays they recommend sunscreen. I talked to a woman in her late 70s the other day who said that her skin has not seen the sun since 1976. She puts sunscreen on every morning. And there have been several studies, this one's from June 2013, people who diligently use sunscreen every day can slow or even prevent the development of wrinkles and sagging skin. Of course, it's very protective with respect to the risk of cancer as well. There was some debate going on about the different types of sunscreen now. I think the consensus in the medical community is that a broad spectrum high SPF sunscreen is the most protective. And then you see things like this. Isn't science life-affirming? Don't you know exactly what to do all the time? Does anybody know what a proper diet is these days? I would like to know. We mentioned with respect to the various functions of skin that it also contributes to thermoregulation. The blood vessels, remember we saw a profusion of blood vessels there at the interface between the dermis and the epidermis. If the body core temperature is elevated for any particular reason, the flow peripherally to the skin is increased. And as blood flow to the skin increases, it carries with it the ability of then the blood vessels to dissipate that heat to the surroundings. Conversely, if it is very cold, the blood supply to the skin will be decreased, thereby conserving the warmth to the interior of the body, to the core. Here, we need one of these little models showing the types of burns. The model here is referring to first, second, third degree burns. I think technically the the terminology in medical literature has gone to partial thickness or full thickness burns. But in any case, this will make the same point that we need to make. You'll notice a first degree burn is superficial, typical of sunburns. Over here, a third degree burn involves not only the epidermis, but significant portions of the dermis, and in so doing destroys all the structures present in that region of the skin, including the sensory structures. So oftentimes these individuals do not report significant pain initially, only later is that more evident. So here's a first degree burn. You can see the lady on the right there with the sunburn. You can see the typical sort of damage there on the left. I remember having several of these when I was a child on my shoulders. But that's the type of second degree burn typically extends down significantly into the dermis, as you can see. And then in the third degree burn, massive suppuration, massive tissue damage. There is the rule of nines explained, I think, best in this graphic over here. All I would want you to know is the significance of the rule of nines as a way to estimate the severity of burns with respect to body area. And you can see the nines, then each surface of the lower limbs is 9%. So the total lower limbs would be about 36%, front, back on each side, 36%. Anterior and posterior trunk, another 36%, and an approximation of the upper limbs and the head, too, all with respect to a multiple of 9. The other thing I would have you keep in mind are the two rules over here, highly variable, highly flexible, no really hard rules, but in general, the burns are considered critical if over 25% of the body has second degree burns, or over 10% of the body has third degree burns. Of course, it will also depend upon where those burns are located. Much more serious if they're on the extremities of the face, head. Sometimes what can be done to address this is replacing the skin and the tissue with skin grafts. This was actually from a rattlesnake bite, but the same type of grafting procedure can be used with burn victims as well. Sometimes involves actually reconfiguring the muscles of the arm in this case. Typically, the pathologies of the skin that you will encounter on a regular basis, acne, affects over 80% of adolescents. Generally associated not with any type of hygiene issue, but with blocked release of sebaceous glands, the oil from the sebaceous glands. That in turn can promote infection. Warts are generally caused by a virus, human papillomavirus. You can see manifestation on the skin here. Cause, in most cases, idiopathic. Do frogs or toads cause warts? No. Although, have any of you seen the Bufo marinus, the cane toad that's so prominent on the other side of the state? Anybody seen a cane toad? Oh, you've got to go see a cane toad. It's where it will change your life. These things are the size of small cars. It was shocking. I walked out I didn't know what it was, but they can get that big. I mean, they're just massive. The problem with these is they don't secrete anything that causes warts. They're just toxic, and they can kill dogs and when the dogs eat them and so on. You will see many manifestations of psoriasis. This is an autoimmune disorder of the skin that has highly variable presentation. Doesn't always look like this, but oftentimes you see the plaques, as you see here. Seborrhea, just anytime you see "ia" at the end, it means excess amount of. So this is just a hyper secretion from the oil glands, and can often give rise to that sort of texture to the skin that you see on the man's scalp there. There are several different types of skin cancer, we've talked about keratinosis earlier. That can arise genetically. It can arise. It's thought that there may be some environmental triggers. In fact, all of these probably have both genetic and environmental components. The three primary types of skin cancer are the basal cell, the squamous cell, and the malignant melanomas. Often a precursor to those is something such as the keratosis that you see here, the actinic keratosis. You're probably not old enough yet, but several, as you get into your 50s anyway, several things you can look forward to are the sigmoidoscopies, the colonoscopies, and then taking the freezing spray to the top of your head, and they will try to render necrotic the region of the skin associated with these keratinoses. Here's a basal cell carcinoma. This is not usually inclined to spread. They grow very slowly. They proceed from the stratum basale. In some cases, they grow deeper into the tissue, but these can generally be treated surgically without much concern. Squamous cell carcinomas oftentimes are found late. They have the ulcerating appearance that you see here in many cases. And these can grow rapidly, and the danger there, of course, is that they can spread to other tissues. That's the major concern with malignant melanomas. There's some exciting new therapies. I heard about one the other day, and they're using some viruses to attack these and various other things to address them. But the problem with melanomas in many cases is that they've already become metastatic by the time they're detected, and they're already present in other tissues. All right, any questions then about there's a little animation I'll let you play up on the website that summarizes the skin. The last unit, the last introductory unit, remember this is the anatomy course. The last introductory unit is just a brief overview of all the systems, and really what we're focusing on here is terminology. You're not expected to know the details or the physics or the rheology of the cardiovascular system. All we want to know for the purposes of an anatomy course is the relevant terminology. So as we begin our discussion of the anatomical systems, we can begin with the cardiovascular system. In general, the illustrations here, you can see the arterial system on the left, the venous system on the right. This is a system whereby oxygenated blood laden with the nutrients, is distributed to all the tissues of the body. We say that arteries, with only a couple of exceptions, always carry blood away from the heart. The veins always return blood to the heart. So the veins would be conducting their fluid at low pressure toward the heart from the periphery. You can see one exception with respect to the oxygenation, not with respect to the flow of blood, but with respect to oxygenation. Pulmonary arteries carry deoxygenated blood to the lungs. Pulmonary veins, veins in this case, carrying oxygenated blood to the heart. Veins bringing it back to the heart. Now, in our anatomy, when we talk about the blood vessels, the neurovasculature, we want to pay some attention to the size and the purpose of the vessel. Arteries are classified by their relative size, the composition, and you can see in the little table here, the little list, there are large elastic arteries. This would be, for example, the aorta and the vessels that emanate directly from the aorta for a short distance. They're called conducting arteries, and we'll see their elasticity is very important to blood pressure, systemic blood pressure. There are then distributing arteries, sometimes called medium muscular arteries, that are important, especially with respect to regulating the flow of blood peripherally. And we'll talk about how the autonomic nervous system regulates the smooth muscle in those vessels to maintain appropriate blood flow and pressure. And then there are the small arteries and arterioles as they approach the capillaries, for example, that have also the ability to regulate blood flow into specific regions. we've used the term anastomosis before. What's an anastomosis? Yeah, branching network, and these are very common in most tissues. Both the arteries and veins are subject to anastomotic branching. We've also used the word reticulation. This is important with respect to a discussion of end terminal arteries. So, for example, I was in a traffic accident many years ago, and we're going to learn that there are blood vessels that perfuse the foot. But the blood vessels on the anterior, or on the dorsal side of my foot were removed. No big deal. Why? Why would that not just cause immediate necrosis? There are other vessels that also, because it's all anastomosing and branching, that can compensate for that loss of vasculature. Oftentimes vessels are harvested. The saphenous in the leg, sometimes the radius vessel in the arm is harvested for bypass procedures of the heart. That's not ideal, but it can be sustained. It can be withstood because there are compensatory vessels, compensatory circulation. All right. In some cases, though, that circulation is not present. So there are arteries in the body, usually called terminal or end arteries, functional or just end terminal arteries. The distinction isn't too important right now, for which there is not a compensatory or backup circulation. So by an end artery, we just mean an artery that is absolutely critical, absolutely essential for perfusion of that tissue, that if it is removed, one would anticipate severe consequences. Significant ischemia, that's probably another term we should be familiar with. What is ischemia?
Blood.
Impaired blood flow. Ischemia implies impaired blood flow. And if the blood flow is impaired, then tissue damage may result. There are a number of end arteries in the brain, for example, that if the flow is cut off, tissue suffers. Then we can do a histological section of a region of the aorta, and you'll notice, in fact, I have several illustrations that are showing the same thing, that the same general organization, the laminar organization, applies to both arteries and veins. Arteries on the left, vein on the right. So we're going to have an outermost layer of the vessel, usually called the tunica adventitia or tunica externa, sometimes called tunica serosa, but whatever term is used implies that it's on the outside. Interior to that is the tunica media in both of them, and the artery, the tunica media, for the most part, is the smooth muscle wall. It's just a layer that's heavily invested with smooth muscle. Generally much less so in the vein, although the vein also has a tunica media. And then the interior epithelium is called the tunica intima, and it may have more, it may have multiple layers or only a single layer of what are called parasites. And then, of course, in the vein, we'll talk about this, but the vein also has valves that are not present in the arteries. So here's the aorta. This is a very large vessel that's capable of stretching, highly elastic. You have a very, very large, smooth muscle, tunica media, and then a rather robust tunica adventitia. In fact, the aorta is so large, each of these regions has its own blood supply. The large pipe requires pipes to sustain it. That's true for even some of the other arteries, but not as large as the aorta. Here we're looking at a large vein, the largest of the veins, the vena cava. So you'll notice, first of all, that the tunica media is much, much thinner, less robust than the tunica media of the aorta. But of course, the tunica intima is adjacent to the lumen of the vessel, and then the tunica adventitia out here. So this, we're going to find out later, this is a much more flexible, a much stretchier vessel. Yeah.
Is the adventitia a connective tissue?
It is indeed. So if we have time, we'll talk about how these words are used. But the adventitia usually implies an exterior connective tissue that is bound to the surroundings in some way. So the differences in the artery and the arteriole are shown here. These are medium size. We can see the artery with the thick tunica media there, much thinner in the vein. And in fact, the wall of the vein generally is less thick than that of the corresponding artery. Here's an arteriole, which would be proximal to a capillary, a venule, which would be distal to the capillary. Notice that at this point, the venule usually is a simple squamous epithelium. The venule usually has just one layer of squamous cells. The arteriole at this point is going to have multiple layers because there's still some degree of flow regulation here. By the time we get to the capillary, though, the capillary is also going to be a simple squamous epithelium. So we talked about that. One of your vexing pathological processes will be arteriosclerosis. And I mention this now only because I want you to be familiar with the derivation of these terms. So what do we mean by sclerosis? Hardening, yeah, generally some type of induration, so hardening of the arteries. Atherosclerosis is a type of hardening, but it's a very specific type, and I'm not even sure that the distinction is observed with complete fidelity anymore. But in any case, in our discussion of the cardiovascular system later, we're going to find that as the arteries become less flexible, less elastic, blood pressure tends to increase. So arteriosclerosis, which can be a pathological process or a process associated with normal aging, tends also to be associated with an increase in blood pressure. We'll talk more about that. Now, atherosclerosis contributes to arteriosclerosis, but has a somewhat different ontogeny, a different origin. In atherosclerosis, you have deposition of these fatty plaques that you see here along the lumen, really growing in the tunica intima. It's called an atheromatous plaque here. And of course, the problem here, not only does it decrease the flexibility, decrease the elasticity of the vessel, but it also narrows the lumen of the vessel, restricting flow of blood. And that can lead to, once again, ischemia, or what is thrombosis? The formation of a clot, and possibly that clot, again, yielding other fragments that can also cause problems to capillaries downstream. Yep.
Is there a difference between an atherosclerotic plaque and an atheroma?
No, they're just, the atherosclerosis is a somewhat dated term that simply implies that the hardening of the wall is due to the plaques. Atheromatous plaque, as far as I know, just refers to the fact that in some cases, in rare diseases, there are other types of plaque. There can be intravascular plaques that are proteinaceous, for example. This just implies that it's, once again, a fatty plaque, usually associated with some type of inflammatory response. We've discussed the function of veins. They're returning blood back to the heart. One of the anatomical or morphological characteristics of veins that are not present in arteries are these venous valves. And because the venous system is at much lower pressure than the arterial side, it can be a problem getting the blood from your feet back to your heart. So the valves in the veins are one-way valves. They're also called check valves. And so as blood is pumped by one mechanism or another, it can't go backwards. The valves prevent the venous blood from going backward, contributing to something called the musculovenous pump we'll look at in just a moment. In the illustration here, this is another term you should know. I should have made more of it. Here it is. Vena commitantes, or venous commitantes, accompanying veins. Now, what we mean by venous commitantes is that in the body, especially in the limbs, the veins usually have approximately the same name as the arteries. And that might lead you to believe that for every artery, every discrete arterial tube, there is another discrete arterial vein, a vein running alongside it. That may or may not be true. In many cases, the vein or veins that accompany the arteries, they look like this. They sort of wrap around the artery. In other cases, there may be 2 or 3 smaller veins paralleling that artery. Whatever the arrangement, that functionally equivalent venous structure is called the accompanying vein or the vena comitantans. I just want you to be aware that it has a highly variable appearance, even looking like this, especially in the upper arm, for example. In the limbs, in both the upper limbs and lower limbs, we also differentiate superficial veins from deep veins. The most important structural distinction, or the most important functional distinction, I think is the better term, is that deep veins typically carry a greater proportion of the blood than the superficial veins. And once again, those deep veins need not be unitary tubes. They can be quite large and radiating and have the complex appearance that you saw before. Superficial veins can often be sacrificed. You've probably seen the varicose veins on the legs, for example. Those would be pathology of the superficial veins. Comparable pathology of the deep veins would have serious consequences. You could have deep vein thrombosis. If those vessels are blocked, that can have not only immediate consequences in that tissue, but consequences distally. And we'll talk about the pulmonary veins as we talk about the respiratory system. This is an illustration of the musculovenous pump. So you're going to be dealing with bedridden patients, patients for whom edema will be a problem. Now, remember the veins in the leg, you're standing up, the heart's up here, the heart has to pump the blood around the body. As the heart does so, and for reasons we'll talk about later, the pressure on the venous side drops dramatically. We're talking, what is your blood pressure right now?
80.
Yeah, 120 over 80, whatever. So you're going to learn that would leave you with a mean arterial pressure in the low 90s. What's the blood pressure on the venous side? So in other words, that's the blood pressure of the blood being pumped from your heart. What's the pressure of the blood returning to the heart?
5.
How much lower? Give me a number.
Like 5?
There you go. Very single digits. Probably, yeah, we could argue about that. So it's very, very low. And so if you have maybe low teens or blood pressures in the distal limb, that's not much pressure to get it back to the heart. So the system that you see here, every time you take a step, your skeletal muscle is compressing the veins in the leg. Let's use that example. And as it compresses the venous blood, the venous blood cannot go back to where it was, cannot go back toward the foot because of this check valve, this venous valve. So it goes backwards. It goes towards the grade. It goes back to the heart in the only direction that it can. So walking, the contraction of the skeletal muscle, the musculovenous pump, contributes to the return of venous blood to the heart. And all of that is made possible by these check valves in the veins of the limbs. All right, we'll stop there this morning, and let's get some lunch, and I'll see you this afternoon for physiology.